Dear students, நாம் இப்போ இந்த வீடியோவில் பார்க்க போகிறது +2 ஃபிசிக்ஸ் டெர்மினல் ஸ்டேட் போர்ட் ஃபர்ஸ்ட் சாப்டர் எலக்ட்ரோஸ்டாட்டிக்ஸ். இது வரைக்கும் இந்த சேனல் சப்ஸ்கிரைப் பண்ணாதவங்க சப்ஸ்கிரைப் பண்ணிக்கோங்க. இந்த வீடியோவில் we are going to study about the energy stored in the capacitor. You know that a capacitor is a device which is used to store the charges. Not only it stores the charges, but it also stores energy. So when a battery is connected to the capacitor, electrons of total charge minus Q are transferred from one plate to the other plate. And to transfer this charge, work is done by the battery. This work done is stored as electrostatic potential energy in the case of a capacitor. Now to transfer an infinitesimal charge dq for a potential difference V, the work done is given by the expression dw equal to V dq, where this V is given by Q by C. So the total work done to charge a capacitor is given by the expression W equal to integral 0 to Q by C dq, that's equal to Q square by 2C. Because here we are charging the capacitor from 0 to a total charge of Q. Therefore the limits are 0 to Q. That you can take it as equation 1.86. And to get an expression for the energy stored in the capacitor, the potential energy is calculated by this expression, and that work done is stored as electrostatic potential energy in the capacitor. So that is the expression is given by UE is equal to Q square by 2C, that's equal to half CV square. Since Q is equal to CV, that's equation 1.87. So this stored energy is directly proportional to the capacitance of the capacitor and the square of the voltage between the plates of the capacitor. But where is this energy stored in the capacitor? To understand this equation, the equation 1.87 can be rewritten as follows. Using the result C equal to epsilon naught A by D, that is the expression for the capacitance of a parallel plate capacitor, and V equal to ED. So the expression for the electrostatic potential energy is given as UE equal to half epsilon naught A by D into ED the whole square, that's equal to half epsilon naught AD into E square. That equation you can take it as 1.88. But this AD is the volume of the space between the capacitor plates. Therefore, the energy stored per unit volume of space is defined as energy density, that is given by UE equal to U by volume. So from that equation 1.88, we can get the expression for the potential energy as UE equal to half epsilon naught E square. So this equation you can take it as 1.89. And this equation you can find out that it is similar to the kinetic energy, that is half mv square. So from this equation we infer that the energy is stored in the electric field existing between the plates of the capacitor. And once the capacitor is allowed to discharge, the energy is retrieved. And what is the important point that should be noted down is that it is important to note that the energy density depends only on the electric field and not on the size of the plates of the capacitor. So this expression 1.89 is true for the electric field due to any type of charge configuration. So this is what the things that you should note down about the energy stored in the capacitor. So we will study about the next topic in our next video. Thank you.